Okay, so let's get started here. This is going to be, I think, our final day on implicit differentiation. So implicit differentiation, day 3. Okay, so we've been doing implicit differentiation so far, which, just a reminder in case it wasn't clear in the first few lessons, okay, what we've been doing with implicit differentiation is we've been taking the derivative of our function with respect to x, okay, because y is a function of x. So for instance here, when we were taking the derivative of, let's just say, I don't know, y cubed plus 2x squared is equal to 3x or something like that. Okay, what we've been doing with this implicit differentiating is taking the derivative of this function with respect to x. So when I did the derivative of y cubed, that became 3y squared, but since y is a function of x, we had to put dy dx in here. Now, when we took the derivative of like 2x squared, we know that that would be 4x, and we didn't put anything after that because if we took the derivative of x with respect to x, it would just be dx over dx, which is just 1. That's why we didn't need to put that in here. Okay, and same thing with 3x. That would just be 3 dx over dx, but we don't need to put that in here because dx over dx reduces to 1. So that's what we were getting when we were trying to solve these out here. And so then obviously we could just go ahead and solve this by subtracting the 4x to the other side, subtract the 4x, so we had 3y squared dy dx was equal to 3 minus 4x, and then we just simply divide it by 3y squared. Okay, so this is what we were doing when we were just doing implicit differentiation. But you want to remember to keep in mind all the different derivative rules that we've used. Because for implicit differentiation, there might be times where we're just doing the derivative using the power rule, but you also could work in the product rule, you could work in the chain rule, or you could also work in the quotient rule. So you just want to be wary of that here. Okay, so let's do a few more examples, and we'll see ones that kind of use all these different examples here. So let's do example 1. Let's do one that involved the product rule again. Okay, so for our instance here, let's find dy dx, okay, derivative of y with respect to x. And our function for this one, let's say it's x squared y cubed plus 2x is equal to 3. Okay, so to use implicit differentiation, what you want to know here is that for this first part, we have x squared times y cubed. This is going to make sure that we have to use the product rule here to take the derivative. So the product rule says we take the first times the derivative of the second. Derivative of y cubed becomes 3y squared, and then we're going to put dy dx, so first times derivative of the second, plus the second, which is y cubed, times the derivative of the first. Derivative of x squared becomes 2x. Now we could put dx, but again, we don't need that. Okay, so it's first times derivative of second plus second times derivative of first. Now we're done with this first part. So then we go to the second part. Derivative of 2x here is just 2. And then it equals the derivative of 3. Derivative of constant is always just 0 here. Okay, so let's go ahead and simplify this down here then. I'm going to subtract the 2 over to the other side. And I'm going to subtract this y cubed times 2x to the other side, which is the same thing as 2xy cubed. Okay. So that leaves me on the left-hand side with x squared times 3y squared dy dx is equal to negative 2 minus 2xy cubed. Okay, now I can rewrite x squared times 3y squared as 3x squared y squared. That's just a better way to write it. And then so if we wanted to find dy dx, we would just divide by 3x squared y squared. 3x squared y squared. Okay, so this is one that involves the product rule. So why don't you try one that has this? So example 2. Example 2. Find dy dx. Okay, and our sample here is going to be 3x to the fourth minus 4xy is equal to 6. So I would like you to pause this video and see if you could do this out on your own here. Okay, so hopefully you took a second to try that out. So now let's go through this together. So what we're going to do here is we take the derivative of 3x to the fourth, which would be 4 times 3 is 12, so 12x cubed. Now here we have to do the product rule. So I'm going to think of this as a negative 4x and a y as my two terms here. So I'm doing the first there, which is negative 4x, times the derivative of y. Well, that's just 1, which means we do 1 dy dx, because we took the derivative of y with respect to x. So first times derivative of second, plus the second, which is y, times the derivative of the first. So derivative of negative 4x is negative 4, is equal to 0. So this is then 12x cubed minus 4x dy dx. Y times negative 4 becomes negative 4y is equal to 0. So then let's go ahead. Let's bring over our 4y here. So we're going to add the 4y over. And we're also going to subtract off the 12x cubed minus the 12x cubed. So we're left with, on the left, a negative 4x dy dx is equal to, and then on the right, we have 4y minus 12x cubed. So the last thing we want to do to get dy dx by itself, if it's negative 4x times dy dx, we divide by negative 4x. And so we're left with dy dx is equal to 4y minus 12x cubed over negative 4x. But we can simplify this, okay, because you could see 4, 12, and 4 can all be divided by 4. I'm actually going to factor out a negative 4. So I'm going to divide everything by negative 4 here. So this becomes a negative y plus 3x squared over just x. And that would be my final answer here. Okay, so I just divided everything by negative 4. Okay, now you could have just divided everything by 4 as well. That would have been the same answer. Okay, but it just looks a little cleaner if you divide everything by that negative 4 there. All right, so that's going to be if we have a product rule here. So let's go to a different one, maybe one that involves a chain rule. So example 3. Or maybe we do a quotient. I don't know. Let's do a quotient rule first. Okay, so find dy dx. Okay, so let's say we had some function here which was 2x to the third over 3y squared is equal to 4. And I wanted to find dy dx for this. Okay, well, in order to do the derivative of this left-hand side, we have to use the quotient rule. Now remember, the quotient rule says that we do the bottom, which is 3y squared, times the derivative of the top. Derivative of the top would be 6x squared, minus the top, which is 2x cubed, times the derivative of the bottom. Now the bottom here would be 6y dy dx. So that all over the bottom squared is equal to, and then derivative of 4 just becomes 0. Okay, so we're going to go ahead and simplify this down here. So 3y squared times 6x squared is going to become 18x squared y squared minus 6 times 2 is 12, so we get 12x cubed y dy dx over 3y squared squared is equal to 0. Okay, well, we want to go ahead and solve this. So I'm going to multiply both sides by 3y squared squared. So 3y squared squared over the 3y squared squared crosses out here. 0 times anything, though, is still just 0. So we can go ahead and ignore that here. And so we're going to be left with 18x squared y squared minus 12x cubed y dy dx. And then we could just go ahead and solve this for dy dx. So I'd minus off the 18x squared y squared. Okay, minus off the 18x squared y squared. So we get negative 12x cubed y dy dx is equal to negative 18x squared y squared. And then we just simply divide by our negative 12x cubed y. Divide by our negative 12x cubed y. And then we just want to simplify this. So negative over negative first becomes a positive. 18 and 12 can both be divided by 6. 6 goes into 18 3 times. 6 goes into 12 2 times. Now x squared over x cubed. Okay. There's 2 ways you can do this. First is when you're dividing with common bases, you could subtract the exponents. So we could write 3x to the negative 1. Okay. And you do the same thing for the y here. Y squared over y to the 1 just becomes y. Which then you could change this around. X to the negative 1 is like 1 over x, meaning you move it to the bottom and it becomes a positive 1. So we get 3y over 2x. Okay, the other way you could have simplified this is if you have x squared, that's x times x. If you have x cubed, that's x times x times x. So 2 of those x's would cross out, and it would leave you with the 1x on the bottom like we have here. Okay, but that would be your answer. So dy dx would just be 3y over 2x. Okay. One last example that you might have here involves the chain rule. So let's just do one here that involves the chain rule. And maybe it might be combined with like a trig function. So that was example 3, right? Yeah. Okay. So let's do example 4. Example 4. Find dy dx. In fact, maybe I'll have you guys take a stab at this first. So let's say we had sine of 4y squared plus 2x is equal to 3x to the 4th. Okay, why don't you pause this and see if you think you might be able to do this. Okay, try it out here. All right, well, now that you've kind of attempted this, let's see if we can figure out what the answer would be. So remember, with sine, if we're doing the derivative of that, sine, the derivative becomes cosine. You keep the inside, which is 4y squared, but then you multiply by the derivative of the inside, which that would become 8y dy dx. Plus, now derivative of 2x is just 2, is equal to derivative of 3x to the 4th becomes 12x to the 3rd. So now we just want to go ahead and solve for dy dx. So I'd simply just subtract 2 from both sides. Subtract 2 from both sides. And we end up here with 8y cosine of 4y squared times dy dx is equal to 12x cubed minus 2. Okay, so then lastly here, we would just simply divide by 8y cosine of 4y squared. divided by 8y cosine of 4y squared. Okay, and lastly here, now that we have dy dx, you would simply just look at your numbers, 12, 2, and 8. Those can all be divided by 2. So I'm going to divide every one of those by 2. So 12 divided by 2 will become 6x cubed minus 1 over 8 divided by 2 becomes 4y cosine of 4y squared. And that would be your derivative here. Okay, so let's have you try one on your own here. Let me go ahead and add a page end. Okay. All right. So I'm going to have you try this out. Example 5. Find dy dx. And our example will look like this. It'll be the square root of 6y to the third plus 2x. Let's do 2xy. Let's combine some of these together here. Is equal to 4. Okay, I want you to go ahead and try this and see if you can come up with the answer. So go ahead and pause this right now, and then we'll go through it. Okay, so let's take a look. Now this one's going to be a little bit harder here. But what I hope you did first was I hope that you rewrote the 6y cubed as 6y cubed to the 1/2. Okay. Plus 2xy is equal to 4. Because now if I take the derivative, we could just use the chain rule of this, which says you bring this down in front. So we get 1/2. You keep the inside, 6y cubed. Lower your exponent by 1, so that'll become to the negative 1/2 times the derivative of the inside. So 6y cubed becomes 18y squared dy dx. Okay, plus, then we have this product rule here, where we have two terms. We have the 2x, and we have the y. So to take the derivative of this, you needed to do the first, which is 2x, times the derivative of the second, which would just be dy dx, plus the second, which is y, times the derivative of the first. Derivative of 2x is just 2, is equal to 0. Okay, so this is what we have so far. So let's go ahead and simplify this down a little bit here. So first off, with this whole part here, half of 18 becomes 9. Okay, so we can rewrite that as 9. So we have 9y squared. Now, 6y cubed to the negative 1/2 is like if we put that over the square root of 6y cubed. Dy dx. Okay. Or actually, you know what? To make this less confusing, let's just leave it like this. 6y cubed to the negative 1/2 dy dx. Okay, plus 2x dy dx. And let's do this. Let's minus off that 2y to the other side. Equals a negative 2y. So now that we have our dy dx terms on one side, we're going to factor out that dy dx. And so we'd be left with 9y squared times 6y cubed to the negative 1/2 plus 2x is equal to a negative 2y. And so then my last step here, I'm just going to go ahead and divide by that whole thing. So we're going to divide this by the 9y squared times 6y cubed to the negative 1/2 plus 2x. And you know what? I'll let you leave it just like that, so you don't even have to rearrange it any farther. And there you go. Okay, so this is how we're going to be using ones that involve the chain rule, the quotient rule, and the product rule as well. In my opinion, the one that we'll probably be dealing with the most, especially going forward with the next topic, which is going to be related to rates, is going to be the product rule. So you're going to want to really make sure that you do have a firm and good grasp on the product rule. But all right, let's go through this now, and we'll do some practice problems on delta math and see how you handle these.